Hello, everyone. Good evening or good afternoon. Welcome to Google. My name is Vasundhara. I'm an engineering lead working out of Hyderabad. I've been with Google for about 11 years. And yeah, I'll be walking you through this session. So I also wanted to introduce what the kind of work we do over here in Hyderabad as well as Bangalore. Engineering these are the two engineering sites that we have, research and development sites that we have in India. Yeah, so about the format, here's the agenda. Feel free to ask questions. We do want to keep it interactive. People on, yeah, so this event is also being live streamed. So if you can turn down the volume of your, uh, phones and mute your laptops, that would be great. Um, People on live stream, please use the comments to check if live stream is working with you or not. And if you have any questions, please post comments. We have Deepak over here in Hyderabad who is looking at that, and he'll pass on the question to us. So let's get started. This is the interview workshop for software engineering positions. Yeah, before we get into that, I also wanted to introduce the site, as I said, right? So in Hyderabad, as well as in Bangalore, we've been working on some really amazing products, right? NBU, you might have heard earlier on from Sundar, our CEO, that we've started this effort on next billion users, right? This is a very focused effort on building products and services for emerging markets, in India included, right? Other than that, we've been working on Google Cloud, enterprise platforms, and apps and machine intelligence, right? Geo or maps, as well as strategic technology. So there's also researchers who are working with us. In terms of apart from the products that we work on, underneath it, what kind of engineering that we actually do, there is like a whole spectrum of engineering that goes on over here. Infrastructure, platforms, we are like both Hyderabad and Bangalore are really known to be good with these infrastructure and platforms. We work on both front end and back end. There's a whole lot of mobile development happening, Android and iOS development. Um, Machine intelligence, Google has always been pushing the edge on what intelligence means and how it can be included into our daily lives. And very happy to see Hyderabad as well as Bangalore working towards that and building them into our products. And also I wanted to, I get this question a lot. Do you work on products that Mountain View has built, and you're just customizing them for the Indian audience? The answer is absolutely no. We are working on products that that are meant for global users, both consumer users as well as enterprise users. We are very good at that. And then yeah and with respect to career growth and opportunities, I just wanted to make it clear that the interview process is uniform across Google, across global engineering, whether it is Mountain View, Sydney, London, Zurich, or Hyderabad or Bangalore. It's exactly the same. We, like, our engineers in India do interviews for other offices and vice versa. And the promotion process is also very, very transparent and uniform across all of Google. And so a staff engineer at Google is uniform, whether it is in India or in Mountain View. It's identical, and it really means something, right? And yeah, I'm also very proud to say that both Hyderabad and Bangalore have been very good with promotion, the rate at which people have been progressing in their careers. We have some really senior engineers who've been with the site for many years. I have with me Rodney, Vaibhav, Nikhil, and a few other engineers who will be joining over here in Hyderabad. We have Rohit, who is one of the very senior engineers in Bangalore as well. we've all been working upwards of 5+ years, right? And we've gotten through multiple promotions over here in Hyderabad and Bangalore, and also like some of the products that we work on, actually not some, all of the products that we work on have a lot of visibility across the board, all the way up to senior management. So like senior VPs, we ourselves go talk to them in one-on-one, as well as in team settings, giving product updates, getting feedback. Our senior leadership comes and takes advice. Yeah, like a lot of brainstorming and opportunity to work with senior leadership, like very senior engineers all across the globe. With that, I wanted to get started on the engineering training session over here. So I've already explained who we are. Uh, I wanted to give an update, overview of what a Google interview is. That uh, the recruiters will typically give this to you, but it has a certain structure. There is a warm-up question. It could be something like, what is the most difficult problem you've worked on, or in any other slightly simpler technical question. But typically after that, there is a long technical question, one or two technical questions. And then finally, there is also some time for you to interview us. It's equally important for, as Google is assessing whether you will fit well into our team. It's also an opportunity for you to ask us questions and understand what Google can offer. Yeah, Google has been one of the more highly the top place to work for in Google and abroad for many consecutive years, and you should definitely ask for what is going on. And yeah, so what is the Google interview about? Again, we are focusing on the software engineering thing. We are really trying to understand the mental model of you, right? As an interviewer, trying to really understand how you think, and think about what. There's a whole spectrum of things. This is by no means a complete list, right? We have 45 minutes per interview to assess a lot of things, right? You can think of user input. How are you, validating input, to how do you write code? Are you thinking about code that can be maintained easily? Is it readable? Can other people read your code and understand what it is doing? A lot of thinking around, are you thinking about speed, scale, performance, right? Privacy and security, right? Because some of these have to be built into the product right from scratch, right? One line of code could actually be a lot with respect to all kinds of things like optimization, performance. How do you build giant systems? How do you break down the problems? How do different components interact with each other? And how do you work with others? Some of the problems that we work on at Google are really complex. It's not something that can be solved by one single person, right? We do need people from engineering, from legal, from product management, from uh, technical product managers, engineers in different organizations to work together to come up with a solution. And it's very important, like your point of view might be different from somebody else's point of view. It's very important to work to a solution that everybody believes is the right way to go. So that is another very important criteria that as interviewers we are looking at. And as I said, this is definitely not the complete list. There's a lot of other things. But the point is we have very little time to go over all of this. Um, so one thing that we are definitely not trying to do is to figure out how much you have memorized. Yeah, you have a question? Did you have a question? No. Yeah, definitely not looking at how much you have memorized. What we are trying to understand is, are you able to write good code? Are you able to analyze problems? What is your approach to solving a problem, right? We are looking at solutions, design solutions. Are you able to, take a particular solution in one setting and adapt it to another problem that you need to solve? Are you able to use data structures that you learned while in college, and use them to solve something that you see in while building a particular product? Can you design data structures? Can you use different data structures and compose them in a way that you can help solve, build bigger data structures and solve problems that way? Can you connect two different components and solve a certain problem? These are all the things that we really want to try and figure out. So yeah, it's definitely not whether you've memorized the n log n, or whether the number of permutations is n factorial versus something else. It's definitely not that. We want to see how you approach the problem. Yeah, so when there is so much that we are trying to assess from the person on the other side, it's very important. Like, these are not very simple problems, obviously. It's very important for you to communicate, right? We want to see how you're thinking. It's not very, like, if you just stand in front of the board and not say anything, it's very hard for the interviewer to guess what your thought process is. So please think aloud, ask questions, right? Sometimes the questions are deliberately ambiguous. We do want to see how your thinking is. Are you going to ask all the questions, right? And then get in depth. Like, we will go very deep into the problems. It's not like, okay, how do you sort, use quick sort, and we are not going to stop there. We are going to go really deep, right? I just took that as an example. Scope out the problem. Like, problem can be very big. Like, you can, sorting can be from a few tens of strings to millions of strings to whatever scale it is. But it's important to understand the scope of the problem that you're trying to solve, and it's better to get that clarified with the interviewer, right? Don't just assume things. That's what I was trying to say. Yeah, and for a lot of questions, I just want to, why it's not like there's a perfect answer, right? System design in general is complicated. Correct is really what gets things done. Everything has trade-offs, right? A solution that works for a few thousand entities or few thousand entries may not be the right solution when you're looking at 1 million, and vice versa, right? So there is no right answer, like a global right answer. It really depends on the scope of the problem, and you have to make trade-offs. Like, you can't use like a giant map reduced to sort like 10 names in a class. Yeah, so there are trade-offs that you want to make. You don't want to use a hammer for everything. And how to prepare, right? Yeah, so there is a lot of theory, a lot of things that we might have learned in school, but yeah, it's very important to review them time to time. How do you do sorting, basic algorithms, basic data structures, nothing very fancy. We are not looking for data structures that require a PhD for it, like, but very basic things, right? Trees, lists, hash maps. And it's not just understanding data structures, but how and in which scenarios do they work and do they not work? What are the limits of that data structure, right? So it's really important to work through a few examples to understand where a data structure works and where it doesn't work, and actually try it out. Like, what if I have to sort over a linked list versus an array, right? And yeah, he also would be great to practice the big O analysis, right? We need to be able to come, like, as I said, one solution that works for a few thousand, a scale of 1,000 may not work for a scale of million. There is that ballpark, right? That is where all these big O analysis is important. When we look at, all the products that we work on work at global scale, and it's very important to understand, a very, a bad algorithm that takes n square might be okay when for the first few, first 100 users, but it will not work when when the product scales to like millions of users. So that is the reason why we are really, really behind and are trying to assess whether people can analyze algorithms and new algorithms too. It, so as an exercise, you could take an algorithm and try to see what the running time of it would look like. And yeah, if you know running times of standard operations on standard data structures, it would definitely help. Like, yes, sorting takes n log n time, and using this particular algorithm versus that particular algorithm, that simplifies analyzing bigger problems because you'll be using these fundamental things while building a bigger solution. Right. Yeah, coding. Definitely practice writing code. Like when you're trying to solve problems, you can go into Google, search for interview questions. You'll find a whole lot of interview questions and a whole lot of solutions. But it's very important to not look at those solutions. Try to work out those solutions on your own. Use a whiteboard to actually go through the whole thinking process. Actually sit down and write the code with proper syntax. It's not just pseudocode, but actual code. You know, run it through the compiler to see whether it's syntactically correct. Pick your strongest language. Pick whichever language you are really strong in, and go with that. Yeah, and understand the language specific functionality as well, and try to understand how the lower level details of memory management, thread management, all of these work in the languages that you know as well. Yeah, I've covered this. Yeah, and when you write code, it will definitely help to remember that things like variable naming, modularization, uh, validation. These are all important things. We cannot take these for granted. So it's good to practice those also. They're usually the easier parts, and people tend to skip them. But they're really important when you build big systems. A small bug somewhere, a small edge in one place could cause havoc. So it's very important to get that right, and interviewers are looking for that. Yeah, and the other thing is interviewing definitely helps when you practice it with others. You can stand in front of the mirror, like do you know interview yourself, but also take your friends, work with each other, and do warm up problems, right? Especially before you come into the interview, right? Do some warm up problems. Yeah, other things to keep in mind is it, how do I test it? Does it scale? When would it fail? What, yeah, do the names of the variables that I used, or the names of the functions that I used, do they make sense? What does the API or the function signature look like? Does it make sense? Because we may be writing code that will be used by many, many different clients. So it's very important to have a good API. Okay, so now that is done, yeah, so the next part of the session is where we do a mock interview. So I have Rodney with me. Rodney, you want to introduce yourself?
Yeah, hi. I'm Rodney. I've been working with Google for 6 years now.
Yeah.
I hope I hear this.
And Rodney has been one of the security experts. Has been building platforms on, yeah, as well as very high performance systems. Yeah. So yeah. Okay. Okay. So I'll be the interviewer, and Rodney will be the candidate. It'll be like you. Right? Okay. So while we do this mock interview, please observe, Rodney. Please pay attention to how Rodney is tackling the problem. What is he doing right? What is he doing wrong? Right? And how does the problem evolve? Right? Okay. Okay, Rodney. Hello, welcome. Let's get into the technical interview straight away. Right? Okay. How do you find groups of anagrams in a list of words?
What's an anagram?
Ah, so like say you have anagram is Okay, two strings are anagrams if uh, the permutation of one is the other. So if you take cat, C-A-T, act is an anagram of cat, or tack is an anagram of cat, right? So all three of these, cat, tack, and act are anagrams of each other.
So do they need to be of the same length?
Ah, yes, of course. Doesn't that mean, yeah. Okay, so how do you find groups of anagrams in a list of words?
So let me start off by thinking about how I can figure out if two words are anagrams of each other. So let's say I take one character in the first word and just search for that character in the second word, and if I find it for every character of the first word, then I think both the words are anagrams of each other.
Hmm. Okay. What's wrong with that? Is- Yeah. So if you have these two examples, cat and act, then yeah, I think your solution works. Did everybody understand? Right? Pick C and check whether it exists in. What if there are duplicates? Like C appears many times.
Oh, I didn't think about that. Yeah, so in this case, it won't work. So I think what I need to do is probably create a canonical representation of the word,
Mm-hmm.
and so that then I can compare. So say I'll create a, I'll sort each of the words.
Mm-hmm.
Uh, I'll sort the first word, I'll sort the second word, and then if the sorted
What
words.
do you mean by canonical again?
So canonical basically means that I want the representation which would be the same for all the permutations of that string. And one thing I can think of is I'll just sort the characters in the word, and so it gives me a canonical representation. I'll match both the canonical representations, and if they are same, then the two words are anagrams.
Character arrays and then calling sort on top of
Yeah.
that. So what is the running time for this?
Uh, so the sort of the word would take n log n time, where assuming n is the number of characters in that word. So n log n for the first sort, n log n for the second sort, and the comparison of the arrays is just order n. So overall, it will be order n log n solution.
You could do a few things though, right? Like if the words are not of the same length.
Yeah. So yeah, probably like for most of the cases, if the length of the words are not same, I could put a check right at the beginning, and that'll it won't go into this solution.
Okay, so now we have a function.
Oh, sorry.
So now we have a function that tells whether two given two words are anagrams or not. How do we convert that into identifying groups of anagrams in a list?
Okay. So I'm assuming that we have m words there, and size of each word is n. And what I'll do, say for the first try, is so I've already uh, s- so I've already figured out that I can check a pair if a pair is an anagram in order n log n time. Then for the all the words which are there, if there are m words, I'll choose pairs of them. So that will be m square words, and for each of those words, I'll get it. So it will be an m square n log n time solution.
Yeah, so that's good. That's a work. I mean, a correct solution. It will definitely be correct, I think. But can we do better than that? M can be large, so M square would be even. Yeah, can we do better than M square?
Yeah, so probably like that, performing the check for every pair of numbers, I think that m square is going large. So for try two, what I'll do is I'll get the canonical representation of every word, which is by sorting that word, which will give me n log n. And then I'll sort all the words which are there based on the canonical representation. And so all words which are anagrams of each other would be together. So I'll sort each word, which will give me an n log n for that word, and sorting all the words would give me m times n log n. Then I'll sort the words themselves amongst, and sorting the words would be m times log m for each word, and the comparison of them is n, so it's mn times log m.
That's good. Uh, Can we do better?
Yeah, we can do better, but just to point out from your side, so there's a small problem in this, right? Because when I compare the words and I move the words around, I lose track of the original. So I also need to keep another array of indexes values and sort them along with the words. So the total complexity here is mn log mn. Uh, Now, can I improve it better? Uh, so I think I'll make use of the fact that there are 26 characters in the word which is fixed. So I could use a different representation for the canonical form. I can use a frequency vector kind of a thing. So I'll get a frequency vector for each word, which is basic.
I like the idea. It's not just that it's 26 characters, but the idea of fingerprinting, right? So as long as the characters in the string, bytes in the string is the same, we should get some value that is identical.
Yeah, so I'll choose an array of size 26, and I'll count how many times a comes and just fill in the first index and so on and so forth. So this I can do in order n time. So I'll create a frequency vector, get it in order n time, and then use a hash map where the fingerprint is the key, and then so all words which have the same fingerprint will end up being in the same hash map row. And so this can be in order mn, and so in order mn complexity I'll be able to get to the solution. Yes. So this is the, yeah, so basically so I take a function which is group anagrams, which takes in an array of strings as input, and I return back a list of strings, right? So each group of anagram is a list of string and a list of that, and then I go over each string from the input, and I put it in an array list, and then I put the array list into the map depending on the fingerprint of it, and I'll just get that.
So that was the end of the mock interview. Um, so, okay, we'll. Yeah. Now I wanted to open up to you and see if you had any questions, observations, comments. What? Yeah, and people on the live stream as well, and Bangalore as well. If you have questions, please speak up. Like what went okay? What did you notice initially? Rodney was just thinking, and for a while he didn't know what an anagram was, right? And it's not, again, anagram. I wouldn't know what an anagram is, but it's best to ask. And once you understand the construct, you can of course build the solution, right? So it's important to ask those questions. And things that I felt Rodney could have asked is, how big is the list? Because that's very important. Like, will it fit in a hash map, for example? In memory? Is the list coming from a file? Is it an array? There were a lot of assumptions made, right? Yeah, assume that the character set is English alphabet, small case. Right. There are a few things, but then once you point out, I think you can fix it also. You can't envision everything upfront. Yeah, but once you do that, and once the interviewer asks, what about this, what about that, you should feel free to iterate and fix the problem as well. And then and then one thing that Rodney did nice was, I recognize there's a problem over here. I forgot to store the index. Point that out and fix it, right?
Yeah. So one more thing I just want to add, right? So we are not looking we are not looking at getting the optimized solution in the first iteration, right? It's fine to go for a simple brute force method if you wish, and then iterate on the solution, right? That also gives us input on your thinking process and how you can iterate and make your solution better, right? It's not expected that you'll get the solution in the first go. And the other thing, when I gave the first solution of how to check if two words are anagrams, I just gave a solution and I felt okay, it's right, right? And so the interviewer had to point out an example where it breaks, where there are duplicate characters, right? So always try to test out the solution you give, and be sure, and that will also help you to improve upon it.
Great. Thanks, Rodney.
Hi, Elizabeth.
Yeah.
From Bangalore.
Hi.
Hey, my name is Janki Ram. Um, I have a doubt. Let's say few questions, right? Whatever is simple to the interviewer might be very difficult for the candidate, where he will start from a simple, less optimized solution. But what if the case is the reverse? The interviewer thinks it's a very complicated problem, but for the candidate it's very simple. In a single shot, he gives close to
Yeah.
the rest of the answer. So how do you take it? It's like you take it as marked up stuff, or you take it for? I mean, what? How do you value the answer?
No, that is fine. Yeah. So the question was, if the candidate gives the perfect answer in the first shot, how does the interviewer perceive that, right? No, that happens quite a bit, and that is when the interviewer will probably start expanding the scope of the problem. Like, what if the strings are really large, won't fit into memory? What can you parallelize things? What what if there are ways of expanding the problem, so to see really how much you can go, and yeah, be prepared for multiple questions. And also, it would be nice if you've seen the problem before, or if the previous interviewer has asked a similar problem. It would be nice to just be honest and say that as well. But yeah, to your point, if you come up with a perfect solution, that's great. Yeah, there's nothing. Anything else you wanted to add?
Is it will be right code on the expert or IDE, or
Sorry, could you repeat the question?
where do we write code on the notepad or?
Oh, so like, it's your preference. So I think the recruiter will share a document with you that the interviewer can see. You can use that, a a Doc. You can write code over there. If you prefer to write it in a notepad or paper, that is fine too. You can use the whiteboard to write whichever you're comfortable with. There's a question. Is it okay to assume that standard data structures and methods are available to use? In which case, most modern languages like yeah, and expanding, say, like stack, queue, push, pop, queue, dequeue. Yes, absolutely. A large portion of engineering is to reuse components, not to reinvent the wheel. So yes, please do use them.
We have one more question here, Vasundhara.
Go on.
So how much time does it take to write that code? So I think logic building will take hardly like if it's up to candidates, we calculate in 10 minutes. So to write that code, what speed should we?
Okay, so repeating the question, how much time do you expect the person to write this kind of code? Uh, we do expect you to write that code pretty fast. What do you say, Rodney?
Yeah, so generally, if we say that we ask two
Yeah, so
two
like,
questions.
once the problem, the algorithm is clear, the solution is clear, we do expect you to, really write it quickly. To translate that algorithm to code, we do expect that to happen pretty fast. Depending on the complexity of the problem, it could be like 10 minutes, 20 minutes. Yeah.
And the other part is, if you get the algorithm and the coding is really huge, it's possible that the interviewer may ask you to write only certain sections of the code. And you so generally, if it's an algo plus coding question, so it's like the code is not expected to be large, but you could have specific, like coding specific questions being asked, which is like, you could say about 30 minutes, where probably it'll be a decently complicated code which you write in those 30 minutes.
And Vaibhav wants to add.
Yeah, just on that point, I think like in general, all interviews, what they look is you being hands-on on coding, right? So the exact coding will depend on the question to question, but you should be hands-on in converting your algorithm into the coding as fast as possible, right? So that's the general idea. It's not like, it's like 10 minutes or 15 minutes or 20 minutes. It will depend on question to question.
Ask any tips specifically for phone screen interviews.
So repeating the question for the audience here, um, are there any tips for phone screen questions? I think you have to be a lot more communicative over phone because we can't see you. And code, yeah, use the shared doc as much as possible. Um, yeah, write clean syntax when it comes to writing the code. Uh, Define your APIs, the function, like the signature, the output, input, that part really clear, and then go into the coding.
So I want to add one thing on phone screen is, when it's a face-to-face interview, we see the candidate writing out something on the paper, so that also helps us understand the thinking of the candidate. In the phone screen, we don't have that advantage, so it's better to think aloud. So if there's a long pause, like, we cannot judge what you have been thinking. So it's like, whatever ideas come into your mind is just good to just say it out, so the interviewer also knows what line you're thinking on.
Yes, there's a question here. The length of the interview, Sheila can answer. Yeah, so it's 45 minutes typically.
Usually give extended it for an hour, but the interview duration is 45 minutes. It's about 15 minutes more of an interaction and trying to understand if there are any questions, what is it about the team, the role, or do it's
So-
for 1 hour.
So, repeating what Sheila just said, typically we schedule 1 hour for the interview. There's a little bit of buffer. We also want to give you a chance of asking us questions. So, yeah, roughly 45 minutes is the guideline. What is the primary thing? Phone screen. It's the same things. Are you able to code well? Are you able to solve the problem? Like, how are you attacking the problem? Are you able to analyze a given algorithm? Are you able to find problems? Are you able to communicate the problem and the solution? These are the things that we look for.
So I think when you come on site, because we get a chance to face, we sometimes can easily ask you like more open-ended questions, design questions. Those things becomes harder on phone screen, so sometimes we do less on the phone screen. But the idea of phone screen is like, so once you are here, it's like, you'll go through like 2 3 4 interviews, right? So just to cut down on false negative there, if like, candidate is not performing well in the phone interview itself, then we'll just cut it there itself. So just a screening thing before you get to on site.
There is a question. Just a point on phone.
Hi. I'm from the staffing team, so my tips are going to be general. But if you're on a phone interview, because the interviewers cannot see you, ensure that you are asking clarifying questions as well. Sometimes, as interviewers, if we are nodding, or if we want something else, we might not be able to communicate that to you. feel free to ask clarifying questions, ask the interviewer what is expected, tell the interviewer I need so much time, or I'm doing this, this is my thought process, give me 5 minutes. Just keep the interviewer engaged also. Ask a lot of clarifying questions on phone than you would in a face to face interview.
I have a question. Um,
Yeah, Bangalore, go on.
okay, thanks. If there are multiple rounds of interviews during the face-to-face thing, does each interviewer focus on different aspects? Like, is one person going to focus on algorithms and the next person on design and somebody else on, performance or something like that?
It's up to the interviewers, really. We try to cover all aspects across, all of us. It's really up to the interviewers.
The design. So just to add to this, we cover all aspects, and at the same time, like if it's a lateral candidate, we would ask more of open-ended design.
Yeah, depending on your experience, we might have different, things that we are looking for. We make, for more experienced candidates, we may go deeper into, bigger systems as opposed to smaller systems. But yeah, you should be prepared for open-ended questions, nevertheless. There's a
There's a question on the live stream. Should we just focus on a correct implementation, or is there an expectation to take some time out to refactor our code?
So the question is there an expectation to just produce the right solution, or will we have time to refactor code? You will absolutely have time to refactor code, existing code, or iterate over your solution. Correctness as well as optimization. It's very much both the interviewer and the candidate working on the problem together. Many times, a lot of problems are like quite open-ended. There's no right solution, as I said, and we are both working on that problem together. I think if there are more questions, we should.
Yeah, so just on this one, I think it also again depends from question to question. It's always good to just check with the interviewer, like what is the expectation out there. Should I make it a little bit more generic, or it is fine to just, do a little bit hard coding and do stuff like that. And then you can also ask the same thing even for the exception catching, input validation and stuff like that. Like, should you go and do all of those things, or interviewer is really looking for the, the real crux and the functionality in the question.
Any other questions? All right, so we'll move on to the. Okay, go on.
The coding and design problems, I understand it's very common and it's very basic for everyone. But what about the civil engineers? You get into architecture, like, this kind of questions, like, how do you Facebook, your Facebook, or how do you build Google search? Do you ask these kind of questions as well?
Yes. So repeating the question for senior candidates, like sometimes they get asked, like, how do you build something like Facebook? How do you build something like Google search? Are they also expected to, uh, you know, get asked this kind of questions? And the answer is, I think we want everyone to be very hands-on. Yes, we will look at big system design, architecture kind of things, but we also do absolutely expect that you will be able to do analysis, algorithm analysis, as well as coding. Like interfaces become really, really important when you talk about large scale systems. Uh, yeah, this and a lot more is what I would say.
So just to add one more thing there, I think as part of this design question, we are also looking for, like how much capable the candidate is to actually navigate through the problem, find out the abstractness out of it, figure out what is the key thing inside it, right? And then go and dig deeper into it. So yes, some analysis, navigating this through and then doing the system design and coding on that.
Like we had a slide earlier that pointed out many different things, right? Are you thinking about security? Are you thinking about scale, optimization? Yeah, all of those are, like, we have to scope the problem. That's a very important thing. All of those come into play. Any other questions? Otherwise, we'll move on to the coding exercise. Okay. Yeah. Okay, so live stream, I'll just put up the coding question over here. But after that, we will break. We'll end the live stream. Please do spend time thinking about the problem. Like resist from looking up solutions on internet. Try to natively solve this. Write code, real code, and try getting that code through a compiler and actually give some input, check output. Please do all of that. Yeah, if you want to take a screenshot, now is a good time. We will be closing the live stream soon. And for everyone in Hyderabad and Bangalore office, we will have a like over here we have few of our senior engineers. We'll work with you through the interview process, and we have Rohit in Bangalore to help you. All right, people on the live stream, thank you for being here. Bye.